Alright, so in this video we're going to learn how to solve quadratic equations in the form ax squared plus bx plus c by factoring. So basically we're going to have a number other than 1 in front of our x squared term. And by factoring, in this video I'm going to show you how to factor by grouping. And if you're not familiar with how to factor by grouping, please see my video that I've linked in the bio, factoring expressions in this form right here, because the only added piece is that I'm just going to use something called the zero product property to solve the equation, but everything else, the factoring piece will stay the same. All right, so let's get started. Erase this. All right, so the first thing you want to do is move everything to one side or set your equation equal to 0. So I can see that I have this 3 over here. I want to subtract 3 because that's a positive 3. So whenever you move anything across the equal sign, remember you use inverse operations. Alright, so it cancels out. So my equation equals 0. So now it is in standard form with my x squared, my x, and then my constant. Alright, the next thing I'm going to do is multiply a and c. So a is, remember, the term in front of your x squared, and c is your constant. So a times c, or 2 times negative 3, is negative 6. I'm going to draw a t-chart, and you'll see why. All right. And I want to find 2 factors of negative 6 that have a sum of 5. So when you're factoring by grouping, you multiply a and c, okay? And you want to find 2 factors of the result that have a sum of b, or the number in front of your x term. So factors of negative 6, or 2 numbers I multiply to get negative 6, but have a sum of 5, are 6 and negative 1. Because if I multiply 6 times negative 1, I get negative 6, which is what I want. And if I add 6 plus negative 1, I get 5, which is what I want. So the 2 factors I'm going to use here are 6 and negative 1. I'm going to replace 6 and negative 1 with the 5. So I'm going to bring down my first and last terms, but instead of writing 5x, I'm going to write plus 6x minus 1x and bring down this negative 3. And you know, normally we don't put 1 in front of the x, but I just put that there to show you that these are the factors I'm using. But normally we would have minus x, all right? And you can actually flip these terms. It doesn't matter. You're going to get the same answer. So it doesn't matter the order. Now, I want to group off my first set of terms, 2 terms, and my last 2 sets. Let's bring down this 0 here. All right? So basically, I want to find the greatest common factor between each pair of binomials. By binomial, I mean it has 2 terms. So right here, this is my first binomial. So my greatest common factor here is 2, because each of them can be divided by 2, each of my coefficients. And they at least have 1 x. So I can pull out one of those x's. All right. Then I've taken away a 2. I've taken away one of those x's, and I'm left with just an x there. All right. Here, 6 divided by 2 will give me 3. And I've taken away that x there. So you can look at it as dividing or removing it, all right? 2x squared divided by 2x is just x. Or you could say, okay, I took a 2 away, I took an x away, and now I'm left with 1x. All right. Here, 6 divided by 2 is 3. Or you can ask yourself, 2 times what will give me 6? 2 times 3 will give me 6. And you took away that x, all right? To check it, you could say 2x times x is 2x squared, and 2x times 3 is 6x. All right. Now to factor this second part here, the only thing that it has in common is a negative 1. And I'm pulling out that negative 1 because I want it to look like my first binomial here. So if I take away a negative 1 here, I'm just left with the x. And negative 3 divided by negative 1 is positive 3. So these 2 binomials should be the same. If they are not, that means you've done something incorrectly. All right. Now I want to take my outside terms here, 2x plus 1, or minus 1, that's a negative 1. If that were a plus, I would have put, or positive, I would have put plus 1. And then I want to bring down one of these binomials that are the same. It's like I factored it out. Now, so hopefully you're familiar with how to factor down to this point. These are the same steps for factoring, all right? The only added piece here is just using my zero product property by setting each one of my binomials equal to 0 and solving. So I'm going to take the 2x minus 1, set that equal to 0, and the x plus 3, and set that equal to 0. All right. And then I just have a two-step equation. I'm going to solve for x. Add 1, 2x equals 1, divide by 2. X is equal to 1/2. So it's just a two-step equation there. So one of my answers is x is equal to 1/2. This is just a one-step equation. Subtracting 3, x is equal to negative 3. So these are my two answers. So again, the only added piece when you're solving these equations by factoring, you factor the same way that you normally would factor, but the added piece is that now you have to set your two binomials equal to 0 to solve it. All right, so we solved this quadratic equation by factoring. All right, so I have one more example here that I want to show you before I have you try one on your own. And as you can see, this is not written in standard form. So of course, the first thing I want to do is move everything to one side to set it equal to 0. So now I have a negative 3x squared. So I want to add that 3x squared to this 3x squared because they are like terms, right? And I want to subtract 6 from both sides. Okay, but I don't have a like term for the 6 over here, so I'm just going to kind of write it to the side of the negative 5x. And so now let's combine my like terms. So 3x squared plus 3x squared is 6x squared. I'm bringing down this 5x because I do not have a like term. This positive 6, I had to subtract it to get it to the other side. So it becomes negative 6. And it now equals 0. So I moved everything to the right hand side. So make sure your first step, again, move everything to the left hand side. Your equation should equal 0. Or you can move it to the right hand side. Doesn't matter, but as long as your equation is set equal to 0. All right. Now, again, I want to multiply a and c. So 6 times negative 6, that is 36, or negative 36. I want factors that equal negative 5. What are my factors? Not 6 and 6, 9 and 4. So 9 and 4, one of them has to be negative. Since that 5 is negative, the 9 should be negative, right? Because if I multiply negative 9 times 4, I get negative 36. But when I add them, right, I do get negative 5. So that 9 has to be negative because I want it to equal negative 5. Now I'm going to replace that negative 9 and 4 with a negative 5x. So that's 6x squared. Let me write it over a little further. Space. 6x squared minus 9x plus 4. So again, you're replacing your factors with that middle term. So this should equal, so negative 9x plus 4x should equal negative 5x. Bring down your negative 6 and equal 0. All right. Factoring by grouping. All right. So 6x squared and 9x, between my two coefficients of 6 and 9, the greatest common factor is 3. They at least have one x in common. So 6 divided by 3 is 2. Or you can ask yourself 3 times what will give me 6. And I took away one of these x's because this is an x squared, so it was 2 x's. So I took away one of them. I'm left with one of those x's. All right. Negative 9 divided by 3 is a negative 3. Now I've taken away the x. Always double check. 3x times 2x does give me 6x squared. 3x times negative 3 gives me 9x. All right. Next, I want to factor this one. Greatest common factor would be a positive 2. 4x divided by 2 is 2x. Because 4 divided by 2 is 2. Now taking away, well, I did not take away x, so I just bring it down. And negative 6 divided by 2 is negative 3. And if you can recall, to kind of help you factor the second binomial, these should be the same. All right. Now remember, next up, group or bring down my outside terms here. 3x plus 2. And one of my binomials here that are the same. And you could also flip it. You could say 2x minus 3 times 3x plus 2. It doesn't matter. It's 0 neither. And then I want to write these equations here, or these binomials, as two separate equations. So 3x plus 2 is equal to 0. 2x minus 3 is equal to 0. So setting these equations equal to 0, I solve, subtract 2. 3x is equal to negative 2. Divide by 3. And x is equal to negative 2/3. So that's one of my answers. X is equal to negative 2/3. Right here, I'm adding 3. Again, just solving the two-step equation. Dividing by 2. X is equal to 3/2. So these are my two answers. I have two fractions. So x is equal to 3/2, or 3/2. And x is equal to a negative 2/3. Alright, so now let's try one on your own. Alright, so I have this problem here for you to try on your own. Remember to move everything to one side and put it in standard form by combining all of your like terms. And so go ahead and pause the video and try this problem on your own. Alright, so you should have got an n equals negative 2 and n equals negative 6/5. Hopefully you got this problem correct. If not, go ahead and just pause the video and analyze my work here a little bit more to make sure you understand how to solve by factoring. And so this is our last problem, and I want to thank you for learning with me.